that particular symbol, it will still retain, it will loop back into the error state. So it will get held, it will get halted here. It goes on looping in this condition. So in this case, you can see that it reaches the error state or the trap state. So this is not the final state. So this becomes the error state. Okay, and the string is not accepted because you have more than one A's. So this is the next problem. So now coming to the sixth problem. In the sixth problem, it's just a variation of the previous problem. So here you can see that we have to construct a DFA to accept strings of A's and B's having at least one A. So the previous one was exactly one A. So this is at least one A. So what would be the language? So before writing the language, first write down the alphabets. So the alphabets that I'll be using is A and B. And what would be the language that it should accept? Since it is at least A, so it should be at least one A. So a single A is accepted, AB is accepted, BA is accepted. And then I can have two A's followed by B should be accepted. ABA should be accepted, BAA should be accepted. Then again, I can have 3 A's followed by B and so on. But the condition should be that it should have, every string should have at least one A and there is no constraints on B, so we are not bothered about it. So as usual, take the minimum string and construct the skeleton of the DFA based on the minimum string. So if it has to accept a symbol A or a string A, so what I do is, I start with the state Q0. On accepting A, it goes to the final state Q1. Now this is a DFA to accept the minimum string A. Now once this is done, so check, you know that this is not a valid DFA because if it has to be a valid DFA, then every state must make one transition per input. Now start with Q0. Q0 is already made a transition on the input symbol A. Now what happens if there is a B? Okay. So, if I have B followed by A, you can see that this is a valid string accepted. If I have two B's followed by A, this should also be accepted. If I have three B's followed by A, accepted. So, one or more occurrence of B followed by A should be a valid string here. So, all that we can do is from here have a self loop on seeing a B. Now all these conditions would be satisfied with this DFA. So a single B and an occurrence of A, you reach Q0. Two occurrence of B and A, you reach Q1, which is the final state. Now come to Q1. Now you can see Q0 has made a transition on seeing a A as well as on seeing a B. Now let me start with Q1. So Q1, what happens when it sees a A? So when do we reach Q1? So if I'm say in the state Q0, basically on seeing a A, I reach Q1. Now, so after seeing a A, we reach Q1. So what happens if I see another A at this point here? So standing in this location Q1, I'm seeing already accepted an input symbol A. What happens if I see one more A? So this is a valid string. It can be accepted because two occurrence of A is also valid. So, 3 occurrence of A is also valid because there is no constraint on B. So, I can have 1 occurrence of A, 2 occurrence of A, 3 occurrence of A and so on. All these are valid. So, anywhere I have this, so try to put a loop here. Okay, now you can see B followed by 2 occurrence of A is accepted. B followed by A followed by any number of A's is accepted. Or a single A is accepted and 2 A's, 3 A's and so on, all these things are accepted here. Now, check for Q1 again. So, it's already made a transition on A. Now, we are left over with the input symbol B. Now, Q1 should make a transition over B. Now, basically, as usual, when I reach Q1, so after seeing, reading an input symbol A, I reach Q1. Now, standing in Q1, if I see a B, so now check this. This should be the valid. So this should be the valid string here. Similarly, A followed by 2 B's should be accepted. A followed by 3 B's should be accepted. And any number of B's, it should be accepted. So what I can do is, I can have a B here. Now you can check for the validity of the string here. So in the similar way, take any string and check for the validity. So you can find out if the construction is correct or not. So I'm not going to do that here because we have done for the previous problems. So I'll go to the next problem. So in the next problem, the problem reads as construct a DFA over A and B which accepts the string AB. Now if you see the string AB, now this language has only one string which is A and B. You don't have anything else in the language. So this is a pretty simple problem. So where you can see that the minimum string is AB itself. So if it has to accept AB, now what would be the transition? Now always remember, first write down the alphabets. So the alphabets that we are using in the language or the symbols that we are using in the language is A, comma, B. Now let me start with the problem. So basically it has to accept a string AB. So I'm there in Q0. On seeing an A, it goes to the state Q1. Being in Q1, on seeing a B, it goes to the state Q2, which is the final state. So this particular DFA will accept the minimum string, which is AB. Now is this a DFA? You know that it's not a DFA. So start having the transitions for the input symbol for which it is not made a transition. Now let's start with Q0. So I'll write the transition states side by. So you can see that Q0 on reading a, it's made a transition to Q1. Now Q0 on seeing a B, we have to find what is the transition. So Q1, so if I'm in the state Q1, on seeing an A, there is no transition, so we have to find the transition. Q1 on seeing a B, you know that it's made a transition to Q2. Now, the state Q2 should also make transitions for the input symbol. Q2 on seeing an A, we'll see what happens. And Q2 on seeing a B, we'll see what happens. Right? So this is a constraint. Now, let's see Q0 on seeing a B. So initially if I have B, now this is a straightforward question because they've given that the string must only have AB. It cannot start with a B, right? It should always have just a A and a B. It cannot start with a B. So if suppose in the start state, if I'm encountering a B first, then it's understood that this should move to the error state or the trap state, which is Q5. So this is the trap state. I'll write it as TS here to indicate that it is a trap state. Now similarly, now this Q0 is made a transition on seeing a B, on seeing an A. Now this point at Q1. When do I reach Q1? After seeing an A, I reach Q1. So when I'm in Q1, now you can see that Q1 is already made a transition on seeing a B. So I'm not bothered about that. What happens if I see a second A? Now again, you know that this string should not be accepted because the language has only one string, which is AB. So when Q0 makes a transition, when it sees an A, all that it has to do is get to the error state because it's invalid. It cannot see two A's. So we will divert it to the trap state here. Now come to Q2. So Q2 again, you can see that because the string is only of length AB. Now when do I reach Q2? After seeing an AB from Q0, after seeing an A, I come to Q1. From Q1, I see a B and then come to Q2. So I've seen AB. Now what happens if I see a A or if I see a B? So this should be invalid or it should not be accepted because my string is of length 2 and it has only symbol. It should be AB. Other than that, it cannot accept anything else. So what I can do, either I see an A or a B from the state Q2, I make a transition to the trap state. Now for this trap state also we are supposed to do the transitions. So being in this state, okay, being in the trap state, if I see a A or B, then it gets looped into the trap state itself. So you can see that On seeing a B, it enters the trap state, which is Q5. Q1 on seeing an A, it enters the trap state, which is Q5. Q2 on seeing an A or a B, it enters the trap state. Now for the trap state also we can write the transition. So on seeing an A or on being in the trap state on seeing an B, so we try to loop back in the same state, which is Q. So this is the next problem. Now coming to the next one. So the 8th problem that I have picked up is construct a DFA over A and B which accepts strings either A, B or BA. So to solve this, again the same thing. So the language is got either AB or it should be BA. So this is what is given. It's either AB or BA. Now one way is this. I'll start with Q0 and then on seeing an A, I make a transition to Q1 and then being in Q1, on seeing an B, I make a transition to Q2. Now because I have OR here, so comma B, comma A. Now if you see this, this is actually a wrong DFA that I have drawn here because this accepts AB, BA, AA as well as BB. So you can see that. Let me check for this condition AA. Q0 on accepting AA reaches Q1. Q1 on accepting AA reaches Q2, which means that AA is accepted by this DFA. So we cannot have a construction in this way. So the better one is, so let me just remove this. So I'll have this minimum skeleton here for the minimum string AB. Now what I do is, I will just have one more transition for BA. So Q0 on seeing an B, it can move to the state Q3. Okay, so this is on seeing an B. Now I'm in the state Q3. On accepting A, it can go to the final state. It can go to the final state, which is Q2. Now you can see that. You can see on Q0 on seeing an A, it goes to Q1. Q1 on seeing an B, it goes to Q2, which is the minimum string. The other option is, I'm in the start state. Instead of A, if I see a B, then I make a transition to Q3. On seeing an A, I can make a transition to Q2. Again, if this is in DFA, you know that it's not in DFA because the state Q1, Q2, Q3 are yet to make transitions for the leftover input symbol. So if you see Q1, Q0 is made a transition on seeing an A, on seeing an B. So it's done. So coming to Q1. So you can see that Q1 is made a transition on seeing an B. It's yet to make a transition on seeing an A. Now again, it's the same usual step. Now, when do we reach Q1? So we reach Q1 after seeing an A. So from this state, I see a A and only then I reach Q1. Now what happens? Being in the state Q1, if I see one more A, right? If I see one more A, you know that this string should not be accepted because it is not present in the language. So what I can do is, so whenever I see such thing, so I can have a trap state here and write this as Q5. And this is when Q1 is seeing an input symbol A. It should not be accepted, rather it should move to the trap state. Now let me come to Q3. Now you can see that Q3 is made a transition to transition on seeing an A. It is yet to make a transition on seeing an B. Now let me start. So when do I reach Q3? If you observe here, from Q0, after accepting an input symbol B, I reach Q3. So after seeing a B, I reach Q3. Now if I see a A, you know that you reach the final state. Now what happens? Instead of a A, I see a B. So you know that this should also not be accepted. So only thing I can do is move this to the trap state. So what I'll do is, on seeing an B, it gets into the trap state. Okay, so you can see Q1 is made a transition on seeing an AB. Q3 is made a transition on seeing an AB. Now let me start with Q2. So Q2 is supposed to make a transition on seeing an A as well as an B. Now, when do I reach Q2? From here, Q0 on seeing an A, I reach Q1. On seeing a B, I reach Q2. Or it could be from Q0. On seeing a B, I can reach Q3. From the Q3, reading an input symbol A, I reach Q2. So it's either AB or BA, I reach the state Q2. Now, being in this state, if I see a A here as the third input symbol, if you see, so just this part of the question is very important. So you can see that it cannot accept this. So what I can do is, or if suppose there was a B here instead of A, that should also not be accepted. So what I can do, being in the state Q2, if I see a A or a B, either after accepting AB or BA, I should ensure that it is moved into the trap state. Now, the trap state also, if it is a valid DFA, then the trap state should also make a transition for the input symbol A and B. So it's always, so for the trap state, any number of A's and B's that it sees thereafter, it would loop to itself. So you can basically take a string and check if the string is accepted or rejected. So here we don't have much string, so it's only AB or BA. So you can see both the condition is accepted. So anything other than that, it enters the trap state. So let me come to the next problem. In the next problem, we can see that construct a DFA to accept strings of A's and B's that has not more than 3 A's. Now this is something important. So you can see that it should not have more than 3 A's, which means that the string should have 0 occurrence of A. It can have strings with 1 occurrence of A, 2 occurrence of A and 3 occurrence of A, not more than 3. So let me write the language. So here the alphabet that it should accept is only A. Okay, so the alphabet here in this problem, we can see that it accepts only one input symbol, which is A. Now let's write the language. So as I said already, so this can take 0 occurrence of A, 1 occurrence of A, 2 occurrence of A and 3 occurrence of A. If there are 4 occurrence of A onwards, this should be invalid, right? So I can have epsilon in the string with 0 occurrence of A. I can have a single A and the alphabets are A and B. So the alphabets here is AB. So I can have AB, BA and so on. Okay. So again 2 occurrence of A's. So I can have AA, AAB, ABA, BAA and so on. So for 3 occurrence of A's, I can have 3 A's followed by 3AB, ABAA, I can have B followed by 3 A's and so on. So all these strings can be accepted. Now how do I construct a DFA for this? Now you can see that it should accept epsilon, it should accept single occurrence of A, it should accept 2 occurrence of A as well as 3 occurrence of A. Now to begin with, so let's start with the acceptance for epsilon. So you know that whenever it has to accept an epsilon or an empty string, the start state itself becomes the final state. So I'm going to write the start state itself as the final state. This accepts epsilon. Now it should accept a single A. Okay. So from Q0, on seeing an single A, it reaches Q1. Now because Q1 should be, A should be accepted, Q1 becomes the final state. Now let me come to 2 A's. Now when I reach Q1, after seeing one A, if I am starting from Q0, after seeing A, I reach Q1. Now there is one more A here. So on seeing the second A, it should reach the state Q3. Now because AA should be accepted, I'll make this as the final state. Now coming to the third one. So you can see that from Q0, on seeing an A, I reach Q1. On seeing an A, I reach, this is Q2. I reach Q2. On seeing the third A, you can see that I can reach Q3. Because 3A should be accepted, I'll write this as the final state. Now one more thing. So now, is this the DFA, complete DFA? This is not the complete DFA. So what we'll do is, we'll try to make the transition for the leftover input. Now I'll start with Q0. Q0 should make a transition on seeing a B. Right? So it should make a transition on seeing a B. So you can see that this string, if suppose I have B, BB, 3 Bs and so on, this string should be accepted because there is zero occurrence of A's here. So only B's can be accepted, right? So in this case what I can do is, if I see only B's, then it should be accepted. So epsilon is accepted here. Any number of B's, one or more occurrence of B's, it can reach the final state which is Q0. So that is accepted. Now when do I reach Q1? On seeing an A or on seeing an B and A, I reach Q1. Let's take the minimum one. So on seeing an A, I reach Q1. Now what happens if I see a B at this point? I see a single B, I see 2 B's, I see 3 B's and so on. All this should be accepted. So what I can do, because there is one or more occurrence of B's, have a loop here. Now you can see, if I have A followed by one or more occurrence of B, it is accepted. A followed by one or more occurrence of B's followed by the second A is accepted. A followed by one or more occurrence of B's and A, it is accepted. So you have 3 A's here. So that's accepted. Now come to the state Q2. Q2 has already made a transition on seeing A. Now we should check for the transition on seeing the input symbol B. Now when do I reach Q2? You know that basically on seeing an A from the start state, on seeing A, I reach Q1. On seeing the second A, I reach Q2. Okay. So what happens if I see a B instead of a third A? Okay. So it should be accepted because this satisfies the condition that I've given there. And then if I have 2 B's, this should be accepted. AA followed by 3 B's, 4 B's and so on, it should be accepted. So I can have a loop here, which is a valid string. Now you can see Q0 has made a transition on AB, Q1 has also made a transition on AB, Q2 has made a transition on AB. What about Q3? Now, so when do I reach Q3? So start from the beginning. From Q0, on seeing an A, I reach Q1. On seeing the second A, I reach Q2. On seeing the third A, I reach Q3. This is basically. So I see 3 A's and then I reach Q3. At this point, what happens if I'm in Q3 and see one more input symbol A? Now if you see, this condition actually tells that 4 A's if it sees, or 3, anything above 4 or more than 4 if it sees, that state should be, it should enter into the trap state. So what we do is, so whenever it sees the 4th A, it gets into the trap state, which I can give it as Q5. Okay. Now, let me come to the next condition, because Q3 should make a transition on B2. So, as usual, after seeing 3 A's is what we come to this state Q3. What happens if I see a B here? Okay. Similarly, AA followed by 2 B's, 3 A's followed by 3 B's and so on. You know that it should be accepted because this is a valid string. So what I can do is, I can have a loop here and then write B here. Now coming to the trap state, this trap state should also make a transition on seeing the input symbols A and B. So whenever there is a trap state, always remember that on seeing an input symbol A and B, it loops to itself. It gets trapped in the error state. So this is the problem, the next problem, and this is one of the very important problem which is asked many times in the in the question papers, in the previous year question papers.